Welcome to this practical guide on covariance. Have you ever noticed how some things in life seem to move together? For example, when the temperature rises, ice cream sales usually go up too. Or when a car speeds up, its fuel consumption increases. Covariance is the mathematical way of measuring this moving together relationship between two variables. To understand covariance, we don't need complex formulas. We just need to look at the direction. Imagine a graph where the horizontal axis is temperature and the vertical axis is ice cream sales. If most data points follow an upward trend, we say they have a positive covariance. This simply means that as one variable increases, the other tends to increase as well. On the flip side, consider the relationship between price of a product and number of sales. Usually, as the price goes up, the number of sales goes down. When one variable goes up and the other goes down, we call this negative covariance. It indicates an inverse relationship, like a seesaw where one side rises while the other falls. But what happens when there is no relationship at all? Imagine plotting your shoe size against the amount of rain in Tokyo. The points would be scattered everywhere like a random cloud. In this case, the covariance is zero. Changes in one variable tell us absolutely nothing about the changes in the other. Now, let's look at how covariance is actually calculated behind the scenes using a central point approach. Imagine we draw a vertical line at the average temperature and a horizontal line at the average ice cream sales. These lines divide our graph into 4 quadrants. In the top right quadrant, both temperature and sales are above average. In the bottom left, both are below average. In both cases, if we multiply their differences from the mean, we get a positive number. If most of our data points fall into these 2 quadrants, the sum will be positive, resulting in positive covariance. However, covariance has a major limitation: scale. Imagine measuring the height and weight of a group of people. If you measure height in meters, you get a certain covariance value. But if you switch to millimeters, the covariance number will explode into the thousands, even though the relationship between height and weight hasn't changed at all. This is why covariance is often hard to interpret on its own. It tells us the direction of the relationship, but the strength is obscured by the units we use. This is where correlation comes in. It's simply covariance that has been standardized to stay between -1 and 1, making it much easier to read. In the real world, covariance is a superstar in finance. Professional investors at firms like Goldman Sachs or BlackRock use it to build diversified portfolios. By picking stocks that have low or negative covariance, they ensure that if one sector crashes, the other might stay stable or even rise, protecting the total investment. Covariance is also the engine behind modern tech. Companies like Netflix or Amazon use it in their recommendation algorithms. By analyzing the covariance between your viewing habits and millions of other users, the system can predict what you'll enjoy next. If you and another user have a high positive covariance in the movies you like, the system recommends their favorites to you. To wrap up, remember that covariance is all about the co-movement. Positive means they move together, negative means they move apart, and zero means they don't care about each other. While it's sensitive to scale, it remains the fundamental building block for almost all modern data science and financial modeling.